Hello guys! The purpose of this video is to review some of the main ideas and concepts surrounding graphical representations of constant acceleration. And then at the end, I'll give you some practice problems to make sure that you have mastered the material. So we're going to be working with two types of graphs. We have position versus time graphs, and we also have velocity versus time graphs. And if you remember correctly, the slope of the position time graph is velocity. Because let's say we had something like this, the rise over run would be change in position over change in time, which is velocity. So in this case, this line would represent a constant slope or constant velocity. But with constant acceleration, we started to see some interesting shapes with these position time graphs. We started to see things that actually had a curve to it. And the reason we started seeing that is because the definition of acceleration is a change of velocity over a change in time. So if we take certain points along the graph here, each of these would represent a different slope or a different velocity because the velocity is changing. So if you graph the slopes of each of those points, we actually can in turn get our velocity versus time graph, which would in this case look something like this. So this graph would correlate to this graph. And if we look closer to our velocity versus time graph, we see that the velocity over time is getting faster. And it's getting faster at a constant rate. So just like the position time graph told us something, given the slope, the velocity time graph can also tell us a lot if we look at the slope. So the slope of the velocity time graph equals acceleration. And we can really see this clearly because if we take the rise over run of any 2 points, we get change in velocity over change in time, which again is the definition for acceleration. So now that we've gone over the basics, let's get some practice in. I want you to look at these 4 position versus time graphs, and I want you to try and analyze what's happening if these were different objects. So go ahead and pause the video and try to identify what the object is doing over time. Alright, let's check out the answers to see if you understood the shape of each of these graphs. So we should have gotten the following descriptions. For the first graph, this is a curved shape and it's going upward. All the slopes are up, so the object is speeding up in a positive direction. The next one is slowing down in a positive direction because it's going from steep to shallow and all the slopes are positive. The next is speeding up in a negative direction because we're going from shallow to steep and all of the slopes are negative. The last one is slowing down in a negative direction. So we're going from steep to shallow again, and all the slopes are negative. So if you got one of those wrong, that's okay. Just make sure that you write down any questions you have and fix your mistakes. So right now what I want you to do is I want you to try and draw the velocity versus time graphs that would correlate with each one of these different graphs. So pause the video and go ahead and try. Alright, let's check the answers. This is what we should have gotten. Let's check out the blue graph here. We said it's speeding up in a positive direction, so that means we want to get faster over time in the positive velocity zone, which is up here. The next one is slowing down in a positive, so we still want to be up here because we're going in a positive direction. We should be approaching 0 meters per second, which is here. So if we're approaching 0, that means we're getting slower, but we're in a positive direction, meaning we're above the x-axis. Speeding up in a negative. So we should be going away from 0 meters per second, and we should be in the negative velocity zone, which is below the x-axis. So all of these we're getting actually faster, but in a negative direction. Here we should be slowing down in a negative direction, so we should be going toward our origin, or 0 meters per second. So we're going from fast to slow, and we're in a negative direction because we're in the negative zone, or below the x-axis. All right, again, fix any mistakes you made and write down any questions you have. So now I'm going to challenge you one more time, and I'm going to switch it up on you. So get ready for this next challenge. This time, as you can see, I give you two velocity versus time graphs, and I want you to try to draw the position versus time graphs. So pause the video, and first I would write down what you think is happening, like a written description of each velocity graph, and then go ahead and try and draw the position time graph, and we'll see how you do. Pause the video. All right, let's check your work. This is what you should have gotten. Let's go over the descriptions first. We should have gotten slowing down, for this first graph here, we should have gotten slowing down in a negative direction, as this is approaching 0 meters per second, so it's going from fast to slow in a negative direction, and then it speeds up in a negative direction because now it's going away from 0 or getting faster over time. And our position versus time graph should represent that as well. Slowing down in a negative, so going from steep to shallow in a negative direction, and then shallow to steep in a negative direction. Now it doesn't matter that you started here where I started. You could have started anywhere along the x-axis, because the velocity time graph doesn't tell us anything about where it starts. It just tells us how fast it's going at each second. Moving on to the blue graph, the velocity time graph, we're slowing down in a positive direction. We're going from fast to slow in the positives, and then we're speeding up in a negative direction. So it looks exactly like this, except here we started in a positive direction, slowed down, and then sped up in a negative. So our position time graph should also reflect that. We should be slowing down or going from steep to shallow in a positive direction, and then shallow to steep in a negative direction. So if you got anything wrong, please fix it and write down any questions you have, and I'm happy to give you more practice problems. Just go ahead and ask me. Thanks.